scatter plots before when you did any kind of, I don't know, an experiment of some sort, and then you're like plotting the data? Okay, so this graph shows the cost of different masses of Macintosh apples at St. Norbert's Farmer Market in Winnipeg. Oh, look at that. So the points lie on a straight line. How can we use the graph to determine the cost of 2.5 kilograms of apples? So 2.5, you could read it, and you'd get this across. Do you see? So what would happen if you were to kind of do that? You'd be estimating. It wouldn't be an actual thing. So is there an actual way that we could actually figure this out? Can you come up with the equation of this? I don't know if you can see the rate of change there. We don't have any data, but we could pretty much estimate it. Maybe we'll just have to estimate it. So what do you think this is going to be? Well, even if the rate of change here, we don't know what this dot is right there, hey? So we pretty much have to estimate. They don't give enough information here. So what would 2.5 kilograms of apples cost about? Yeah, probably $3.25, I would say, is a good estimate. Okay, and what about 3.5? 3.5 would be right here. So that looks like it's going like that. It almost looks like it should be there, maybe a little bit below there, but what do you think? I would say $4.50, $4.46, just a little under, hey? See, the thing is I'm not using a ruler here. If I were to use a ruler and I actually extend it, it looks like it actually does go right through the money for $4.50, hey? Yeah. Okay, so lesson learned, use an actual straight edge to draw it, and then you're a little bit more accurate. Does anybody know the difference between reading 325 and reading 450? This is from grade 9. There was 2 terms for that. Yes. Yeah, this is interpolation. Do you remember this term from grade 9? That's where you read within the data points, and then extrapolation means you extend the line to kind of go if the trend continues, right? Extrapolation. Okay. Are these costs approximate or exact? Yeah, it's going to be approximate because we were pretty much kind of guessing there. Okay, let's go to example 2. Crickets make chirping noises rapidly sliding one wing over the other. Did you know that's how they made their noise? Some say no, some say yeah. The faster they move their wings, the higher the chirping sound that's produced. Scientists have noticed that crickets move their wings faster in warm temperatures than in cold temperatures. Therefore, by listening to the pitch of the chirp of the crickets, it's possible to tell the temperature of the air. Who knew? The table below gives a recorded pitch in vibrations per second of a cricket chirping recorded at 15 different temperatures. So, which one is the independent variable? Yeah, the chirps per second. We don't have a listed variable for it, hey? And the dependent is the temperature. Looks like the temperatures in Fahrenheit and the chirps per second is there. Okay, let's plot this. Let's plot this. Let's plot this. So I've conveniently labeled the scale for you so you don't have to worry about that. So 20 is 89. Okay, so this is going to be approximate because you see 90 is there, so it's just going to be a little bit lower. So don't be all, I know some people have to have exact. You're going to have to let that go a little and go with, it's going to be approximate, right? Okay, I like putting a little check mark by the ones I plotted so I know I didn't miss anything, but you don't have to. 16 is 72. 20 is 93. By the way, is this a function? No, it already failed, hey? 1884. Okay, so they're kind of all clumped together like that, hey? Okay, I hope everybody has a ruler. Does everybody have a ruler? Okay, so, whoops. It says here, use a ruler to draw a line that best represents the data. This is called the line that best fits. The line suggests a possible relationship between the two sets of data from your graph. Estimate the temperature at which the crickets would be silent. Okay, so let's go down here, back. Oops. Let's go back. And so here's the thing. You're kind of taking your line and you're kind of just changing it to see if you can, where it goes through most of the points there. So for instance, like if I think mine is going like this, I don't know, is that a line that best fit? I kind of have it going, some of them are, you might say, oh, maybe I need a different slope. This is like almost like an opinion in a way, but you see part of mine are above, part of mine below. I might adjust it so that, is that a better fit? It seems like it's hitting it a little bit more. Or I can move it like that. Is that hitting it better? What do you think? Okay, if you think you got a good line, extend it all the way so that you can see what the temperature is when the chirps are silent. So what was, did you get 40 like I did? What did you get? You got 20? Yeah, it's not automatically going through 0, 0. You have to kind of rotate it to see, based on your line that best fits. You might say that some of these below are outliers and these are more of the trend. You know what I mean? Yeah, I think your slope is a little off there. Okay, so I don't know, approximately 40 degrees Fahrenheit. Can you estimate what would it be at 60 degrees Fahrenheit? Now use your line to do this, right? So you might, mine might be off of yours. So 60, if I go across and then go down, it looks like it would be about 8. What did you guys get? You got 6? As long as it's something close to what, so approximately, what did I say, 8 chirps per second? So go across to 60 and see where it hits it going down. You got 8 as well. Okay, using 2 points on your line that best fits, you're supposed to find the rate of change. Remember, rate of change from yesterday, we learned that the rate of change is the delta y over delta x, yes? So take any 2 points on here and figure out the rate of change here. It doesn't even have to be your data points, but it's probably better to use your data points. For instance, I don't even know what this one is, but I kind of see my line going through those 2 data points there, which would be 1884, and this one is 1476. Did your line go through those 2 points? You might have different ones that it goes through. Okay, so then if it's going up to the right, so I know my rate of change is positive. So now I need to measure how much I'm going up and across, right? Oops, let's try that again. Up and across. So what's my change of y? Looks like for me, it's 10 and 4. What did you get? So if I divide that, I get 10 divided by 4, which is 2.5. I guess it's degrees Fahrenheit per chirps per second. 2.5? Did you get something close to 2.5? You got 3? Yeah, something close. You didn't get like 10 or anything like that. If you got 10 or something, then I would say we're a little off. But so now we're going to approximate the Y-intercept. Does everybody remember what the Y-intercept was? There's my Y-intercept, right? 40. What is 40 what? Is yours 40? What's yours? It should be the same answer you got in C, right? Make sure you have units. So what's the approximate Y-intercept of your graph? 40. Did anybody get anything different? 38. You got 20, eh?
I was like 42.
42. I'd have to look to see how you drew your line to make sure. Okay, so given that the equation of best fit is in the form the approximate change, rate of change times the independent variable plus the approximate Y-intercept, we're going to come up with this. So our dependent variable was the temperature. So which variable do you want to call that? T? T for temperature. My rate of change was what again? 2.5. 2.5. My independent variable was the chirps per second. What do you want to call that? C for chirps. Okay. C. And then it's plus approximately the Y-intercept, which mine was 40. Okay, so does everybody see how I came up with that equation? You may have remembered this from grade 9. It may not be so explicitly stated like this, but remember that in grade 9, if we had something like this, 0, 1, 2, and this was, say, 10, 8, I don't know, 6. Remember you were trying to find the pattern as what's going on. If it was going down by 2, then this meant it was y equals negative 2x, and then your starting value was the plus 10 there, yes? And the reason why that worked is because your rate of change, you're changing, you're going down 2, and your change of x was going up by 1. So you're really taking 2 and dividing by 1. So it didn't work, though, in grade 9 if it wasn't going up by 1s. Then you had to know a little bit more. Okay? So we're not really going too far. Next unit, we're going to go way into finding equations of lines. But, okay, how would we use the equation in G to determine the temperature at which the crickets would chirp 25 times per second? Where would I put the 25 into this equation? T or C? C. So I would go T equals 2.5 times 25 plus 40. And what do we get for that? I got 102.5, and that would be degrees Fahrenheit, right? Okay, so let's look on my graph to see at 25 times per second if that's accurate. So 25, if I look across, does that look like a 102.5? Kind of looks like it, doesn't it? Something to note here. I saw a couple people, they just wrote 2.5c plus 40. What's wrong with that? They didn't put the t equals. So is that an equation? No, that would be an expression. The person that did it is not even listening to me, actually. If it asks you for equation, it has to have an equal sign and a left side and a right side for you to get full marks. It's not just 2.5c plus 40. You need to have t equals, right? Okay, so let's move on. 13 owners of 6-year-old vehicles were surveyed as to the number of oil changes and the cost of repairs. So we're going to plot this. I'll give you a moment to plot this. This is all nicely done. Okay, so did yours look like this? So definitely the rate of change is positive or negative? Negative, yeah. It's going down for sure. What is the independent variable? The oil changes per year. And the dependent is the cost. Make sense? Does that make sense to you? If you do lots of oil changes, I guess it's better for your engine or whatever. Okay, let's use a ruler to find the line that best fits. The nice thing about this is we have a y-intercept and an x-intercept. So it's almost like I want to connect those in there. Would that be the line that best fit if I actually went that way? What do you think? More or less, hey? I could change my... It's funny, like in an Olympic scoring, they get rid of the lowest mark and the highest mark, and then you're supposed to just look at the middle. But yet, you know...
It's like the curve.
Huh?
It's like the curve.
It's like the curve. What do you mean? Yeah. How do you know about the curve in university? Does that look a little bit better if I go like that? Yes. Where's the what? 2-300? Where did I get that from? Do I not have a 2-300? Oh, did I put it in the wrong spot? 3-300. Where's... Oh, that might have been just me. That might have been... Is there a 2 there? 2 650 and 2 500s. There's a 500. And 2 650 I got there. That might have been... Sometimes when I click off, I get whatever. So what do you think? Is that better than going through 610? Okay, let's see. I think, yeah, you kind of have some below, some above, and you have to try to intersect a few of those, right? Okay, so we're going to use the ruler that we did that using your 2-point line of best fit to determine the rate of change. I'm thinking I want to use this one right here and this one right here. I don't know what they are, though. I'll have to look it up on my chart. That's the 3 one. Looks like 3-400. 3-400, and this one was 7-150. Okay, so measure the rate of change. So what's the difference between 400 and 150? That would be 250. Is that correct? I'm doing this in my head. And then dividing by 4. So I divide that. Minus 62.5. Did anybody get anything different?
No, I got
60? As long as you're getting minus, and probably around there, it's probably about the same. Okay, and... Oh, okay. 400 minus 150. 7 minus 3. Remember, it has to be the change of x, the change of y, right? And I know it's negative because it's going down to the right. Does that make sense? Okie dokie. What's my equation then? Cost equals my rate of change, which is negative 62.5. What are we going to use for oil changes per year? The only thing with O is it looks like a 0.
Y for year.
Or C for changes.
But we already have C.
Or N for the number of oil changes.
Or M for money. Or that's the other one.
No, C for cost.
Yeah. Or
N.
R for repair.
No, but it's, the repair is the cost of the repairs over there. So N for the number of oil changes. And so what's my y-intercept? Did you get 600? Oh, I already... Shoot, I'm putting this answer in the wrong spot. Ah! This it should be here, hey? Let's try this again. The rate of change was minus 62.5, and my y-intercept was 600. So does everybody see this goes into there, this goes into there? Yeah? And that's all I got. We should have units here, so that should be $600. Yeah, and the rate of change